Welcome everyone. In this video, I'm going to explain how video streaming works between client and server using RTP and RTSP protocols. RTSP stands for Real-Time Streaming Protocol. It is an application layer protocol, whereas RTP stands for Real-Time Transfer Protocol. It is a transport layer protocol. In this type of communications, the client requests the server for a media file, and the server will send the data between to the client, send the media data to the client using RTP packets in the form of RTP packets, and the whole communication between client and server will happen through RTSP protocol. This was a setup that will present at client side and server side. Client side, there will be two sockets, one for RTSP and one for RTP communications, respectively. Similarly, at the server side. So the client will send the RTSP request, which includes the instructions that need to be sent to the server, like play, pause, setup, etc., which is used to control the flow of incoming video. And after analyzing the request, server will send an appropriate RTSP response. In addition to that, it will start sending the media data using RTP packets. So here in the server side, the media data will be encoded into RTP packets, and it will be sent to the client in the form of RTP packets. And at the client, the decoding of these packets is done, and the client uses the media data from after decoding these RTP packets. So this whole communication will have a session ID to identify this particular session, as RTP is transferred. RTP transmission is done over UDP, whereas RTSP transmission is done over TCP. So a session ID is maintained at both at server side and client side to verify that the packet received was from the server only and not from any other outside sources. So let us have a quick demo of how this server and client works. So this is the Python implementation of it. Let's start the server file. Here we have to provide the port number, and the server starts listening at this port number. I am providing 1500, and we have to start the client program also. Client launcher. That's right. Here we have to pass the IP address and port number of the server. As it is running on the same machine, I am passing localhost, and we have to also pass the RTP port number. So the client will listen for the RTP packets from the server on this port number, and finally we have to move the file name which we want to request to the server. Here I am using a temporary file movie.mjpg for this streaming. So when setup is clicked, the connection will be established between client and server, and when play is clicked, a RTSP request will be sent to the server. The server sends RTP packets which contains the video data, and when pause is clicked, the video streaming will be paused, and when tear down and when play is clicked, again the transmission will continue, and when we click on tear down, the process ends and the client program will exit. So let us look at the implementation of this. These are the files used for this used to implement this. First, let's see the video stream.file. It's act like a media server at the server side. It will process the video file that the client requested, and it will extract frame by frame then from that video. This video will consist of a multiple frames of JPEG images. So this video stream class has a method to extract frame one by one, and each frame is associated with a sequence number. So using sequence number, the server knows which frame to send, and this video stream file will extract the frame, and it will return the data that contained in this frame, and The server will convert this into an RTP packet and it will pass to the client. So this is RTP packet class. It is used for creating of RTP packets at the server side and decoding that RTP packets at the client side. So let us see the encoding implementation. Here all the variable here the RTP packet contains of header which is 12 bytes and payload. The variables that are present in the header are passed to this encode function and also with the payload which contains the actual media data. So the encode function will create the header format which will be like this. This is the header format that we are using for these RTP packets. There will be three rows. Each row will contain 4 bytes of data. So this this is byte 1, byte 2, byte 3, and byte 4. In byte 1, we have fields like V, which stands for version. It is of 2 bits of data, and P stands for padding 1 bit of data, and so on. And here the sequence number is used to represent each frame. So sequence number is used to identify which frame is currently transmitted. It is of 2 bytes and timestamp and synchronization source identifier fields occupy 4 bytes each. So the encode function will create this type of header in the form of array. So first each the array contains of the array is of size 12. Each position in the array will represent a byte in this header format. So the first byte, which consists of version, padding, extension, and CC, is created like this. First, the version is shifted 6 positions to the left. So the version initially version will be present here. After shifting 6 positions to left, it will be aligned in its current position. And similarly, padding is shifted 5 bits, extension is shifted 4 bits, so that this format will be created finally. Similarly, for each byte the corresponding fields are getting added into the byte. Mm, After doing it for all the fields present, our header will be generated, which contains 12 bytes of data total. And the RTP packet payload will have the payload data, which contains the video data. And after encoding, a RTP packet will be created. This packet is transmitted to the client, and at the client side, these decode functions will be used, which will be used to retrieve all the variables that we have encoded here. Like decode will separate header and payload from the received RTP packet, and version will extract version from the header. Sequence number will extract sequence number from the header, and so on. There are methods to get each field, and these are the helper classes that will use it in at the both client side and server side. So let's first look at how server starts. Initially, this is the code for the server. Initially, the server will create a RTSP socket at the IP address provided, and it will bind as it is a TCP connection. It should bind the port number with this IP address to create the socket and starts listening for the incoming requests. Here, 5 represents that the maximum queue size is 5. I mean, when when the server is accepting one request and other received requests will be kept in a queue. The queue size, the maximum size of the queue will be 5. So when the server is accepting one request and more than 5 requests are received, then the 6 requests will be get eliminated as the queue can contain only maximum 5 elements, and it will start accepting the request from the client, and whenever a request is received, it will accept it, and it will start a new server worker file, and runs the new server it will runs the it will start a new server worker file. So this server worker is used to communicate to that particular client, and the server can accept other requests, other incoming requests, and while this server worker file will communicate with the particular client. So if you open the server worker file, then initially it creates a new thread in the server worker file, and the method receive RTSP request will be run on that separate thread. So as the connection is established between client and server, now the server waits for the request from the client. So as soon as it receives any RTSP request, it will call the process RTSP request function. In this process RTSP request function, the function will first extract the type of request and the request code and the version and all those file names, sequence number which the client sent. So according to the request type that the client that is received from the client, appropriate response will be sent and appropriate action is taken in the server side. This is the state diagram of the client state. The client will be initially present in the init state. When setup request is sent, it will move to ready state, and it is ready to accept the video RTP packets that are being sent by the client, sent by the server. And when when play request is sent, it will move to the state playing, and now it will parse the incoming RTP packets from the server, and it will start playing the video that is being sent by the server. And when pause is pause request is sent, it will again go to the ready state, and at the any time when teardown is clicked, everything gets ended and the client will exit and it will return to the init state again. So these are the variables. The state of the client and server should be the state of the client should be maintained at both the server and the client. So when it is in the ready state, it should not permit setup request, as setup request is only possible when the client is in the init state. So the state variables should be stored at both the client side and the server side, and these are the variables that will be stored for each of the commands that the server will get from the client. And these are the states. Initial state is being init. These are the states for init, ready, and playing. So upon receiving the request, the server will extract the data like what type of request, what is the sequence number of that is present in this request, and accordingly it sends the response. So if the request type is set up, it will create a new session as the communication is starting now, which it will create a new session ID between a 5-digit session number and randomly, and it will send this to the client. So when a play request is being received, it will start a new thread in which it will start sending the packets one by one. So here it will start. Here it is starting new thread, and it is starting using the function send RTP, which extracts video data from the file and converts it into packet using the RTP packet.py class, and it will send the RTP reply RTP packets to the client. And similarly, when pause request is received, then the thread will be stopped. The thread which sending the RTP packets will be paused using this client info of event.set function. It basically stops the thread which is running, which is sending RTP packets. And if a request of teardown is received, then it will stop the sending, and it will close the connection to the RTP socket of the client, and make RTP function which will create the packets from the frame number. It will extract the it will first extract the frame number from the data, and it will create the packet, and reply RTSP function is to send RTSP reply to the core, RTSP reply to the client. Okay. So depending upon the code, if it is success, it will send 200 code, and if the file number passed by the client is invalid, then it will send a 404, and similarly it will send 500 error connection. This is the this is how server functions. Now let us see the client function. So first, client launcher.py will accept the command line arguments like server IP address, server port number, RTP port number that is to be created, and file name. And it creates the window using printer, and it will let us have a look at the client side code. Initially, the client will set up all the variables that it needs to maintain, and it will create a connection to the server. It will request for a connection to the server using the connect to server method. In this method, an RTSP packet is being created, RTSP socket, and a request is made for the server to establish a connection. And after this, an RTP pack socket is being created. It is used to listen for the incoming RTP packets. Here, listen RTP function will wait for the incoming RTP packets, and when any data is received, it will parse the data, it will decode the data using the RTP packet class, and it will extract the video data that is present in there, and it displays to the user the received data. And here there are methods that will be executed when buttons are clicked. So when setup button is clicked, its RTSP request is sent to setup. An RTSP request is sent to the client. When pause button is clicked, and a pause request is sent. Similarly, when play button is clicked, a play request is sent, and along with that, a new thread is created which starts listening for the RTP packets. And when teardown button is clicked, a teardown request is sent to the server, and the client will exit. So here, let's see the RTS send RTSP request function. So it will receive a request code. After receiving a request code, depending upon the type of the request, it will send the appropriate request message to the server. So when it is set up, when the request code is set up and the client is in the init state, a new thread will be created, which is used to listen for the RTSP reply. After sending RTSP request, it will receive RTSP reply. So it will create a new thread and starts listening for the RTSP reply from the server, and it will create a string in the given in this format, setup plus file name, and in the second line it passes the sequence number, and in the third line it passes RTSP version and the type of protocol it is using and RTP port number. So this port number is where the client had created an RTP socket. So the server will use this port number and sends data to it will, after creating the string request string, it will send the data, it will send this request to the server, and it will update the variable request end which is set up. Similarly, when play request should be sent, it creates a string with the first as a command name play, and in the second line sequence number, and in the third line session ID. And similarly, when pause request is received, it will create the request string for pause and add the session sequence number and session ID, and it sends the request after encoding it. Similarly, when teardown is received, the teardown request will be sent correspondingly. So after setup, after connection is established, this receive RTSP reply will run in a new thread. It will wait until any data is received from the RTP socket, any RTSP socket, and when any reply is received, it will call the parse RTSP reply function, which will so this parse RTSP reply function will first get the reply from the server, and first it will check whether the sequence number that the server sent is corresponding to the sequence number that client is requested for. And if it is true, then it will also verify the session ID. If the session ID is 0 initially, then it will update the session. Otherwise, it will check if the session ID corresponding to the current session or not. If it is true, then it will take the action according to which type of request, which type of if the previous request was setup request, then it means the client will be moved to ready state, init state to ready state. So the state is updated. Will open the RTP port. It means the RTP socket is created initially, but now it will be get binded to the RTP port number so that it can receive the packets. And if the request sent is play, then it will update the state variable and it will clear the event on the thread. Request sent was paused, then the state is updated, and a set function, a play event dot set function is used. This function is used to stop the thread as we are running a thread to listen the RTP packets, and when we send a pause request, we don't have to listen to RTP packets anymore. So this event is set which will process the thread, and similarly when play request is sent, the event which initially processed the thread will be cleared so that not the thread. Similarly, when a teardown request is sent, the state will be updated again to init and the tear acknowledgement variable is set to 1. These are the functions that will control the flow of the communication, and some other functions like to create the buttons and all, and to write the incoming data frame to the display, etc. Here, when any frame is received, a temporary image file is generated, and the frame is written into that image, and the image is being displayed to the demo once again. So when setup is selected, we can see that the request that is sent to the server contains the setup command and the file name, and then the sequence number and the details like RTP version and RTP protocol user and the RTP port number of the client side. So when play is clicked, sequence numbers are being transferred between client and server, and when pause is clicked, the server will stop the sending, and when play is clicked again, it resumes the transmission. And when takedown is clicked, everything will be shut down